Okay. Now we shall do problem number
14th complete பண்ணுங்க.
14th complete பண்ணனும் இல்லையா? 14th okay. 14th we didn't okay, we just started. So in this problem see, you will be, yesterday you were asking a doubt like when to use Hess law and when to use the equation directly. Like I told you the formula, right? Del H is equal to heat of formation of products minus heat of formation of reactants, isn't it? So when in the equation, see last class we saw an equation N2O4 plus 3CO giving N2O plus 3CO2. Here there is an equation given, and in the problem the heat of formation of all the reactants as well as products are given. If the values are given directly, heat of formation, then you can write, you can substitute the heat of formation of the products in the equation minus heat of formation of reactants. You can use this formula directly. But if it isn't, if the formation enthalpy is given in the form of equations, okay, then you you have to add or subtract the equations according to your target equation as required by the target equation. Then you have to calculate the heat of particularly if heat of formation is asked. If heat of formation of any one of the reactants or products is asked, then you can go for Hess law. Here in this case, heat of reaction is asked. So you substitute the heat of formation reactions, heat of formation values given directly in this formula and calculate. Okay. So if heat of formation of one of the reactants or products is asked, then you can go for an individual heat of formations are given in the form of equations. Then you can add or subtract them according to your requirement and proceed. Okay. So that way, this problem, 14th problem, in this problem, what is asked? The standard enthalpy of formation of methanol is asked. Okay. But the combustion enthalpy of methanol is given in the equation. See here, methanol plus 3O2 gives CO2 plus 2H2O. And del H naught for this is minus 726 kilojoules per mole. And for combustion enthalpy of carbon is given. Combustion enthalpy of carbon. Enthalpy of combustion of carbon is the enthalpy of formation of carbon dioxide.
Excuse me, ma'am.
Yes.
I cannot see your screen, ma'am.
Now, others, are you able to see?
Yes, ma'am.
No, ma'am, I cannot see it, ma'am. Can I just cut my
I can
call?
see, ma'am.
Yes, yes, you have to log out and come.
Yes, ma'am.
Enthalpy of formation of water is also the enthalpy of combustion of hydrogen. Burning of hydrogen in enough amount of oxygen gives water. Got it? Now, what is the, given these equations, now you write the target equation. What is the required equation now? What are you asked to calculate? Can anyone tell me what are you asked to calculate in this problem? Yes. What is asked in the problem? You have to give the answer. Yes. Read the problem and tell me what is asked in the problem. Nikita?
Yes, ma'am.
What is asked?
Ma'am, I just now joined the class, ma'am.
Who else? Chandrasekhar, Dilip, Adira, anyone?
Del H, ma'am.
LH, standard
Enthalpy.
enthalpy of what? Everything is standard enthalpy only.
COH.
Standard enthalpy of
CH3COH. Formation of CH3COH.
then CH3COH here. CH3OH, right? Methanol. Formation enthalpy of methanol is asked, right? So, how will you write the formation enthalpy of methanol? Formation means methanol is formed. So, formation enthalpy means how do we define it? We have to consider the equation which involves the formation of this product from its corresponding elements. What are the elements present in methanol? Can anyone tell? What are the elements present in methanol?
Carbon, hydrogen, oxygen.
Yes, carbon, hydrogen, and oxygen, right? So, in what ratio would they combine? Here, there are 4 hydrogens on the right hand side. So, you have to put 2 H2 here. Carbon, only 1 is there. Oxygen, here 2, here 1. So, what should we do? You put half mole, right? Now, this becomes a balanced equation. For this, we need del H naught. Del H naught for this is asked. Standard formation enthalpy. That is why we have put naught. Okay. So we arrive, now we have to use, now the formation enthalpy of methanol is asked. But we have the combustion enthalpy of all the elements as well as methanol here. So we have to add or subtract these equations in order to arrive at the target equation. Okay. Now, can you tell me, let me number these equations as 1, 2, and 3. Can anyone tell me whether I can use the first equation as it is or should I reverse the equation? Yes. First equation, should I take it as it is? How should you decide whether, yes?
We should reverse the first one.
Very good. Why should you reverse? Because on the first equation, methanol is on the left. But in the target equation, where is it? It is on the right. Okay. So our requirement is that methanol should be on the product side. Right. So we have to reverse this equation. So we have to reverse this equation means what? Just add a minus to all of them. Right. Or let me write minus na this will go this side, right? So let me write shall I go to next page? It will be more comfortable there. Okay, we are reversing the first equation. So in the first equation, CO2 will come on the left. What else is on the left? Right side, whatever we have, that will come to the left, right? 2H2O will come to the left. And what will go to the left? Whatever was there on the left will go to the right. So methanol plus 3/2, right? So when you are reversing the equation, what should I do to the del H? I should reverse the sign of del H also. So what should I do?
Plus 226.
Plus 726 it will become, right? Then what should I do to the second equation? Should I retain it as it is or should I change it? Should I reverse it? Yeah,
We should keep it as it is.
We have to keep it as it is. Why? Because compare the second one and the target equation. The second equation, carbon is on the left. The target equation also, carbon is on the left. So retain it as it is. So we have to add as it is. So C plus O2 gives CO2. For that del H value, no change. What is that? Minus 393. Unit I am not writing. Hope you know it is kilojoules per mole. Then what? What else we have? Next one, hydrogen. Hydrogen, what should I do? Should I keep it as it is or should I change? Or should I do any other change to this? What all changes should I make to hydrogen equation?
Multiply 2.
Very good, Dilip. You have to multiply this by 2. Why? In the third equation, I have only 1 mole of hydrogen reacting with half mole of oxygen. But in the required equation, target equation, I have 2 moles. So accordingly, I have to change the third equation. Good. So 2H2. If I am multiplying this by 2, the entire equation has to be multiplied by 2. So 2 into half will be 1, right? This will become 2. So if I am changing this, if I am multiplying this equation by 2, del H naught value also should be multiplied by 2, right? So what should it become? What will be the multiplied, after multiplying by 2, what will be the result?
572.
Good, 572. So shall I write this? Are you all able to follow? 2H2 plus O2 gives 2H2O. Del H naught is, how much is it? 572.
Yes, ma'am. Minus 572.
Yes. Minus 572 kilojoules per mole, right? Now, I have to cancel whatever similar reactants, similar compounds or elements, if they are on the left and right, I have to cancel them. So I have 1 plus 1, 2 oxygen molecules on here, but this side you have 1.5. So if you cut 2, this side you have 2, this side you have 1.5. So when you cut these 2, I will have some remaining half mole of oxygen will remain here, right? And carbon and hydrogen, you keep it as it is because this side you don't have carbon and hydrogen. What else can I cut now?
2H2.
Correct. 2H2 I can cut. What else?
CO2.
CO2 also I can cut. So what will I get? What will remain now? C plus 2H2 plus half O2 gives CH3OH. So am I not getting my target equation? Is it not? So by adding these, by reversing the first equation and multiplying the third equation by 2 and adding, after doing these changes, when I add all these equations and cut out the similar molecules on left and right, I get the target equation. So after doing these changes, I have to, for the changed del H naught values, I have to add. So these two are negative, so I have to add these two. Minus 393 minus 572 is how much? 5, 6, 9, minus 965, 726. What is the result? Tell me. Yes, fast.
Minus 239.
Minus
239.
239 kilojoules per mole. That means what is the meaning of this? Enthalpy of formation of methanol. Methanol is CH3OH. The value is minus 239 kilojoules per mole. Here 1 mole of methanol is formed from its corresponding elements. So the value that you get here is the formation enthalpy of methanol. Is it clear to all? Copy this down fast. You need the previous page also to copy.